Welcome to Financial Analytics. In today's session, we will discuss exploratory data analysis in R. It is very essential to understand available data or given data to us and to understand the interrelationship among the variables. And if we understand our data initially, that will help us to make a valid assumptions about the data and develop the hypothesis and make a valid conclusion based on those assumptions. So we have to essentially understand our data and before digging it into a more depth. So we need to understand how many columns are there. Is there any missing data? And if there is a missing data, then how we are going to handle that missing data, whether the data is a missing row wise or whether the data is a missing a column wise, whether we are going to delete entire column or whether we are going to sacrifice few rows. So understanding the data in that context is very essential. So data exploration helps us to find out the outliers in the data. What are the relationship among the variables? What are the hidden pattern in the data? So data exploration help us very a lot, and R is a powerful tool which help us data exploration. So let's move ahead, and these are the stages in a exploratory data analysis. So first we import the data which is available. We can import the data through Excel file or CSV files. Then clean the data. In data cleaning, we have to find out what percentage of our data is missing, how many rows we have problems, in how many columns we have problems, and then according to the context of the data or a business problem, we have to clean that data. Now, after the data is clean and the data is ready for statistical analysis, what we do first in exploratory data analysis, we find out the summary of a summary statistics of a data, like mean, median, mode, or we get the summary, first quantile, second quantile, median, or minimum number or range. So we get a summary statistics and we understand how the data is spread. What is the standard deviation, what is the variance. So what our objective at this stage is to find out whether the data is symmetrical or not. And in last stage we see visualization. We plot the data and find out how the data looks like. We can create a bar plot, we can create a scatter plot, we create a histogram to find out the normal distribution of a data. So these are the stages. So first we import the data, then we clean the data, then we have a summary statistics of the data, and then last we have visualize. So summary statistics looks like in this way, and this is our plots, scatter plot, histogram, and then again we can see here the scatter plot. So let's move ahead. Before moving to RStudio, let us understand what is the data set that we are using for today's session. So this is a future Fortune 500 companies data, to which we can see here there are 10 columns and there are 500 rows. Each row represent one company. For example, this is the first row, and in company column you can find here is the Walmart. The second row is related to Berkshire, third row is related to Apple, fourth row is Exxon, and in similar way there are 500 rows. So first column is related to rank, second column is related to company, third column is related to number of employees working in that company, then previous rank. In fifth column we have revenues, and then revenue change, then profit change, assets, and market value. So this is the data to which we are going to explore. Now in data cleaning, we have to remember that this is a column of revenue to which there are some problems. You can see here in this data there is a comma attached to these numbers, as well as before the number there is a dollar sign, and entire revenue column has this problem. In this column, you can see revenue change is calculated and there is a percentage sign attached to this number. We have to remove that percentage sign, because if we don't remove, the R will interpret it as a character. So we have to remove that percentage. So data cleaning is very essential stage for this file. And then in profit, similar, there is a dollar as well as a comma that we have to remove. In profit change, we have to remove this percentage sign. In asset, there is a dollar sign and a comma that we have to remove. And in market value, we have to remove dollar as well as a comma. So let's go to our studio. Let us understand which are the functions that we can use in exploratory data analysis in R. I have imported my file and named it as a future 500. So my data is now in future 500. And if I want to check the first few lines of this future 500, I will write the future 500 and write n is equal to 1. Why n is equal to 1? Because I only want to see a first line of data. And now you can see here, there are these columns: rank, company, number of employee, previous rank, revenues, revenue change, profits, profit change, assets, market value. So these are the columns, and this is the first row of our data set. Now the first row is a column is a rank, and then second column is a company name Walmart. And you can see here the number of employee. We will face the errors because you can see here there are comma attached with the numbers. Similarly, you can see here the revenue column. In revenue column, we have a dollar attached with the numbers, as well as there are a comma. In revenue change column, we can see here the percentage is attached with the numbers. And in profits, we have a dollar as well as a comma. And then per profit change, we have a percentage sign attached with the numbers, so minus 0.72%. So we have to remove this percentage, otherwise the code will not run. So we have to clean this data. In asset, again, we have a dollar as well as a comma attached with the number. Similarly, market value, we have a dollar as well as a comma. So this that cleaning, data cleaning we have to do. So if I want to see the internal structure of a data, I will write here, give me a structure of a future 500, and then we will get the internal structure of a future 500 file. So this is basically data frame. There are 500 observations and 10 variables. 10 variables means we have a 10 columns. And see, you can see here the rank, company, number of employees, all these are the columns. But what is the most critical part of this data frame? Where is the problem? You can see here is the problem. R has converted the number of employee, which are the numbers, but due to these commas, R has converted into a characters, and they are in a double quotes. So we have to remove these commas attached with this number, and then we will convert it into a numeric form. So some data cleaning is required for number of employees. Then this revenue column, revenue change column, where we have to remove this percentage sign. Then we will have a data cleaning for this profit, because we have to remove this dollar as well as this comma. So next is a profit change. We have to remove this percentage attached with this number. In asset, we have to remove dollar as well as a comma. In market value, we have to remove dollar and a comma. So let's move ahead. And what we will do, we will first try to find out how many missing data is there. So I will write a function is.na, and is.na will find out the missing data. Now, what this is.na function will check each and every variable in the data set, and if there is a data, it will return a false. If there is a missing data, it will give a true. So this is basically false and true that R will return with this is.na function. But we are not interested is.na. We are interested, give me a sum of is.na of future 500 file. and now you can see here there are 8 missing data points. Now what is the most important? When we find out there is a missing data, we are interested in finding out where exactly the missing data is, whether the columns are affected or only one row is affected. So we have to check that. So I'm using a function apply and give me is.na of future 500 file, and it has 2 dimensions, so I'm writing 2, and then give me the sum. And now you can see R is returning me this, where the rank has a 0 missing data, company has a 0 missing data, number of employees has 0 missing data, and I know there is 8 data points which are missing, and they are in this column previous rank. So I have to exclude this missing data, so 8 rows will only get affected. So I have 2 options: either I will remove entire column of a previous rank, so out of my data frame previous rank column will get deleted, or second option is only I have to remove these 8 data points, so only my 8 data points, 8 rows will get deleted. So I will prefer this loss, because I have 500 rows and I will prefer to delete 8 rows and clean my data. So after I delete 8 rows, I will have a 492 variables. Why I have a 492 observation? Because check the str of future 500, you know, here you can check here we have a 500 observations. So when I am deleting 8 rows, there will be 492 observations. So let's move ahead and then write down is dot na dot omit future 500 and store it into new future 500. So I am deleting my 8 I'm deleting these 8 data elements, so my 8 rows will get deleted, and that will be stored into this new future 500 variables. So I have new future 500 now, and if I check the internal structure of new future 500, you can see here there are now 492 observations. Because why we have 492 observations? Because we have deleted 8 data elements, so 8 rows has gone, and now 492 observations are there now. But we know about our data is stored in a variable new future 500, and if I simply check its head, give me a head of a new future 500 data where n is equal to 1, and you can see here in the third column number of employees. The problem is that there are commas attached with the number, so we have to remove those commas. So we are using g sub function for it, and if you check the type of new future 500 and number of employee column, this column number of employee is a character data type, and we cannot use statistical operations on a character data type. So we have to convert this character data type into a numeric data type. So let us see how we can do it. So write new future 500, give me number of employee column, and then I am writing here g sub function. And after writing a g sub function, first write the sign what you want to replace. So I want to replace a comma, so I am writing comma inside a single quote. We can use a single quote as well as double quote. And then I am writing, then write what you want to replace. I want to replace it with nothing, so there, hence I am writing it here only a double quotes, and there is nothing inside it, that means there is nothing. And then write new future 500 dollar and number of employee. And if we check now the head of the data, you can see the number of employee and there you can see the 23 lakh and commas has gone now. But if you check the type of new future 500, give me number of employee column, you can see still it is a character. The problem is that we have not converted into it numeric format. So how we can do it? So to do that you have to use the as dot numeric function. So I am writing that earlier code, copying earlier code, and I'm simply writing as dot numeric before this g sub function, and that will convert our character data into numeric data. So, and now if you check the type of new employee column, it gets in, it converted into double. So our number of employee column is now used ready for statistical operation. Now if I check the head of a data, I can find a problem here in revenues column. So there are dollars as well as a comma. So we have to replace dollar as well as a comma, and also the revenue column is also of a character data type. So I have to remove that character data type with the numeric data type. So let's move ahead, and new future 500, uh, give me revenue column, and then g sub function, and then what I want, what I have to replace, I have to replace dollar as well as a comma, and then I have to, I'm using two operations here. I have to use dollar as well as a comma. So I am writing it in a square brackets and giving backslash, two backslash, and then I will write here single quote. What this single quote, what this single quotes means, replace this dollar and comma but with nothing, and then new future 500 and revenue. Now if I check the head, you can see here in a revenue column the dollar as well as commas has gone, but still if you check the type of new future 500, number of revenue column is still, it is a character. So how we convert character into a numeric data type? So simply copy this code and paste it here, and write here as dot numeric function. So that will convert character data type into numeric data type, as dot numeric. And now if you check the type of revenue column is double, or it's now converted into numeric format. So if we check the head of our data again, you can find problems here, percentage, and now you have learned how to correct or how to remove this percentage sign. Again here there is a percentage sign, you can remove it, and here you have to remove dollar as well as the commas. Here in market value column you have to replace dollar as well as a comma. To save our time, I am moving ahead. Now this part you can do it on your own. So let's move ahead. Save our time. I have cleaned our entire data, and now if we check the internal structure of a new future 500 file, you can see the rank is in integer, there is no problem. Company is a character, there is no problem. Number of employee, all are in a numerical format. Previous rank is in integer format. Revenues are in a numerical format. Revenue change is in a numerical format. Profit numerical format. Profit percentage change is also change numerical format. Asset is change numerical format, and market value is also change numerical format. So our data is now clean and there are no problems. So data is ready for statistical analysis. So let's move ahead for the data visualization and to find out the summary statistics of the data. So head new future 500 m is equal to 1. Now what we will do, we will try to find out the average number of employees in this future 500 companies. So I will simply write a function mean. Give me a mean of new future 500 companies of number of employees, and the answer is that the mean number of employees in this future 500 companies is 55,712. And if I want to check the standard deviation of this data, new future 500 companies and number of employees, so SD is used basically for standard deviation. So standard deviation is 1,22,863. Similarly, we can also check the revenue. We simply write, give me a summary data or summary statistics of new future 500 companies revenue, and we have here summary statistics. The minimum revenue is $5,145. Median is 11,384. The mean or average sales is $24,066. Third quantile is $22,243, and max sales is $48,000, $4,85,873. So in this way our data of revenue looks like. Similarly, we can also check the summary of profit. So new future 500 and give me the profit. And now you can see the minimum number is a minus 6177. That indicates that the loss is $6,177. That is the minimum number for one company. The average profit is $1,802. Maximum profit is $45,687. So in this way our profit data looks like. Now coming to data visualization. So let us understand data visualization in exploratory data analysis. And first we will check our data and what kind of a data visualization we can do. So the third column is related to number of employees. So we can check the employment level in these companies. Then we can create a histogram of this profit, so we can understand how many companies are loss making, how many companies are profit making, and what kind of extent the profit they are making. Then we also can plot this revenue column against the asset column. That will help us to understand what kind of income these companies are generating by employing the assets. So let us move ahead, and I have one code, and that will generate this plot. And in this plot you can see the index first. What is this index? This index is a 500 companies. So there are 500 companies, so you can see from 0 to 500 x-axis. On y-axis you can find the employment level. Now I have used this plot function to create this plot. Then I have used this color, and in this color I have used this if-else statement. Now due to this if-else statement you can find out the blue as well as red dots. Now I have asked R with this if-else statement, give me 1 lakh companies which have employment level beyond 1 lakh and make it blue. So due to this if-else statement, if a company has employment above 1 lakh, then it is making it blue, otherwise it is a red. So what these red dots indicate, these red dots indicate that these are the companies which has the employees below 1 lakh, and this blue dot indicates that these are the companies which has the employees above 1 lakh. So if I check here 4 lakh, is there any company which has the employment above 4 lakh? Then I can see here there are only three companies. So these are three companies which has the employment beyond 4 lakh, and rest of the companies which are the red dots have employment below 4 lakh. So in this way we can interpret this. Now next is we will plot a histogram of a profit. To create a histogram, we have to write histogram of a new future 500 and give me profits, and we can get this bar plot. But the problem is that there is only a gray color. What we will do, we will make a separate color for each bar. So we will use this rainbow function and give me 7 colors in the rainbow, and now you can better see this plot. So this is the histogram of a profit, and most of the data, 80% of the data is scattered in this green bar. What exactly is this data tells us? First understand, our histogram tells us that here is a 0. On x-axis we can find out the profit. So profit start after 0. So here you can find out a 0. So after this point profit started. So what is below this profit is a loss. So there are 50 companies in this yellow bar. You can find out there are almost 50 companies which are making loss in these future 500 companies. So because the scale on y-axis is between 0 and 100, and yellow chart you can find out at a 50 level. So there are 50 companies which are making profit or making loss, and there are almost 3 or 4 companies you can see in this region which are making a loss approximately near to $10,000. So in this way you can interpret these loss making companies. Now there are 400 companies in this green bars because near 400, and these are making a profit between this 0 and $5,000. There are a few companies, almost 20 or 30 companies you can find in this area which are making a profit between $5,000 and $10,000, and accordingly you can interpret this risk chart. So at this point, if you find out there will be 2 or 3 companies which are making a profit between $20,000 to $25,000. So in this way we can interpret this histogram. And let's move ahead and create a scatter plot. To create a scatter plot, write down a plot and give me a scatter plot of a new future 500 revenue against new future 500 companies profit, and our data will look like this. Rather than this new future 500 on x-axis, what we will do, we will bring this assets here. First of all, we will make it assets here and send these assets on x-axis. So we are changing x and y-axis in this way, and now you can see here the asset we have bring it on x-axis and revenue is now on y-axis. Now use the colors. So color is equal to, and you learn how to use the if-else statement, and you can use the if-else statement to find out how these companies are using their assets and against their revenue. Now you can find out here there is an outlier. A company is having highest sales with this company, and this company is employing assets below $5 lakh. So there is a cluster of these companies which are generating a similar style of us or similar amount of revenue, where they have a similar amount of fixed asset. But this is a company which is entirely outlier, which is generating significant amount of revenue by employing less amount of fixed assets. So what kind of this function company may be? This company may be a tech company, and because a tech company employs few level of assets, so it may be definitely it is a tech company. So you can also see outliers in this region. These companies are employing high level of fixed assets, and they are not able to generate a significant amount of revenue as compared to this cluster. So this is the interpretation of this plot. So in this way you can do exploratory data analysis and use in your projects or use in your research. So let's move ahead to next video.